Right, our last example is a financial example. We have a student borrowing $20,000 for college, so she initially collects $20,000 and uses that to pay her tuition, and then she agrees to pay off an annual interest rate of 5%. And so she's going to make her payments continuously at a rate of $1,000 per month. So the idea here is that every month she's going to pay $1,000, that's a constant, but at the same time she's got this large balance which is building up interest. So we have to write an initial value problem to describe this situation, and then we don't actually have to solve it in this example, but we should determine how we could figure out when the loan will be paid off. So let's go ahead and set this up. I'm going to set up a couple of variables. I'll go ahead and work up here. So my t is going to be time, as usual. And my y of t is going to be the amount of money she owes at a given time. So amount owed at time t. And I should put some units on here. So my time, there's sort of two ways you could go with this, because there's an annual interest rate, but then she's making payments every month. So we have to decide which one we want to use here. And I think it'll be a little easier if we work in terms of months. So we'll measure time in months. And then the amount that she owes, we'll measure that in dollars. And so we're going to write an initial value problem. That means we need to write an expression for y prime of t. And remember our strategy for that. Y prime of t is the rate at which y is changing. So that's always an increase. And then there'll be a decrease. So let's think about what each one of those would represent. The increase, what's making the amount that she owes increase? Well, that's the interest. As she keeps the money, interest builds up and she has to pay back more later. So the increase is determined by the interest. And the decrease is determined by the rate at which she pays it back. So the decrease is given by the payments that she makes. So the interest that she pays is dependent on the amount that she owes at any given time. So the amount that she owes at any given time is y of t. And then it says that she's borrowing at an interest rate of 5%, but that's an annual interest rate. So what that means is that every year she would have to pay back an extra 5% of what she owes. So 5% is 0.05, but we're measuring things in terms of months. So every month her interest rate would be 1/12 of that. So I'm going to put 0.05 divided by 12 there. That reflects the monthly interest rate would be 0.05 divided by 12. And then the decrease is coming from her payments. Now the amount of payments she's making is $1,000 per month, so I'll put minus 1,000 here. And so what we have is y prime of t. That's a y prime there. Y prime of t is equal to 0.05 over 12 y of t minus 1,000. What we've done there is we've written a differential equation that describes the amount she owes at any given time and how it's changing. We also need an initial condition, so that's the amount she owes initially, which is $20,000. So y of 0 is $20,000. So that together gives us an initial value problem because we have a differential equation describing the increase and the decrease and an initial condition describing the initial amount that she owes on the loan. Let me point out a couple of things here. Remember, I said at the very beginning of this lecture that you'll always have an increase and a decrease, and generally one of them is constant and one of them is dependent on the current value or the current quantity that you're keeping track of. And this is a really good illustration of that because the payments she's making are constant. That means she's paying $1,000 a month no matter what. Every month she pays $1,000 irrespective of how much she actually owes. But the interest that is building up on the loan is dependent on the amount that she currently owes. So this interest depends on the current value of y. The more she owes, the more interest builds up. And so at the very beginning of the loan, she's building up a lot of interest. Then later on, as she gets some of it paid off, she won't be building up interest so fast. So the second part of the problem here says, assuming you could solve the equation, describe how you would determine when the loan would be fully paid off. So that was our answer to part A right there. For part B, what you would do is you would solve. Well, we want to figure out when the loan will be fully paid off. So we want to figure out when she owes $0. Well, y of t is the amount she owes, so you would solve y of t is equal to 0. And so that'll tell you what the time will be when she owes $0. And for a little more explanation here, the answer for t is the number of, remember t was measured in months. To completely pay off the loan. So if you could solve this differential equation, and actually you could, it's a linear differential equation, so we could solve it using the techniques that we learned in the previous lecture on linear equations. But if you went ahead and solved this differential equation, then in order to figure out how long her loan is going to last, you would solve y of t is equal to 0 because you're trying to figure out what time it would be when she owes $0. And then whatever you get for t, you would say it's going to take that many months to pay off the loan. So just to recap here, we wrote our initial value problem. We set up our variables. T is always time. Y of t is the quantity we're keeping track of, which is the amount she owes at time t. Got to be careful about your scale here because part of the problem was given in months and part of the problem was given in years. So we said, okay, we're going to make our time scale be months. And then y prime of t is the increase minus the decrease. And we have to think, what's making our quantity increase and what's making our quantity decrease? Well, our quantity is the amount that she owes. So that increases as interest builds up on it, and that decreases as she makes payments. So the interest depends on how much she owes at any given time. And we said it's 5% interest, so that's 0.05, but that was an annual interest rate. So our monthly interest rate, you just divide that by 12. So that's where that 12 came from. That was the conversion from years to months. And then her decrease is just the fact that she's paying off $1,000 a month. So we just subtract $1,000 from y prime there. So that gave us the differential equation. The initial condition reflects how much she owes initially, which was $20,000. So we got our initial value problem. That would be a linear differential equation, so we could solve it using our techniques. But the question just asked how we would figure out when the loan would be paid off. So in order to do that, we set y of t is equal to 0, and then the answer, whatever we get when you solve that for t, would be the number of months to pay off the loan, because t was measured in months. So that's the end of our lecture on applications, which is also known as modeling and is also known as word problems. Any of those three different phrases. They all kind of mean the same thing in the context of differential equations. These are the differential equation lectures here on Educator.com. I'm Will Murray. Thanks for watching.